Hey everyone, Mr. Newman here. We're going to learn about quadratic functions, and let's go ahead and get started. So first of all, a quadratic function is just a polynomial of degree 2. By degree 2, I mean that the highest exponent on the variable is 2. So you see I circled that there. There are two forms that we typically write quadratics in that you'll see. Each has their pros and cons. Vertex form is a nice form because you can quickly find the vertex, and it's actually a good way to graph starting with the vertex, and I'll show you two examples of that in a moment. The vertex, if you write it in this form, is always h comma k. Now notice that's x minus h and then plus k, because as you guys remember, whatever you do to the input, it always does the opposite of what you expect. So that's why we need that minus right there in the middle, okay? All right, the other form is called standard form. This is what you normally see quadratics in, and that's a way you can quickly find the y-intercept, for example. In this case, it is c, so whatever doesn't have an x on it, you can find c. And the reason for that is because if you plug in 0 for x, that's the y-intercept, and anything multiplied by an x is going to be 0, so all you're left with is c. All right, let's graph these two vertex forms. So first of all, x plus 3 squared minus 2. The vertex is going to be right there at negative 3 comma negative 2. And what I want to do is I want to plot the points as if I'm just graphing a quadratic, as if I'm just graphing a parabola. So since the formula is x squared, if I go right 1, I'm going to go up 1. If I go right from the origin 2, I'm going to go up 4. So instead of thinking of it as the origin, now I'm thinking of it from the vertex. So if I go right 1 from the vertex, I'm going to go up 1. If I go right 2 from the vertex, I'm going to go up 4, because 2 squared is 4. If I go right 3 from the vertex, then I'm going to go up 9 from the vertex. And so this is a way to quickly plot the points. You could make a table of values and do all that stuff, and that would be just fine, but this is a much faster way to graph this. Likewise, if you go left 1, because negative 1 squared is positive 1, we're going to go up 1. If you go left 2 from the vertex, that blue dot, then negative 2 squared is positive 4, so you go up 4. And same with left 3 from the vertex is going to be up 9. And then we just connect the dots. Now let's talk about a few features of parabolas that we need to notice. First of all, that is the vertex, negative 3 comma negative 2. In this case, the vertex is a minimum, but it isn't always. If the parabola were concave down, then it'd be a maximum instead. Remember, up like a cup, concave up is the way we have it now, and down like a frown would be if we multiplied the whole thing by negative 1. So if a up here, from the vertex form up here, if a were negative, we'd be concave down. All right, other thing we have is that, that's the vertex, and you can see it in the form there as well. The other thing we have is something called the axis of symmetry. This is a vertical line that if you flip it over that vertical line, then you'd get the same parabola, so that's why it's symmetrical over that line. And in this case, the axis of symmetry is x equals negative 3. Lastly, we have our y-intercept and our x-intercepts. There aren't always x-intercepts, but there is always a y-intercept. You can think about that. And yeah, we'll look at those more another time. So let's graph this other one. I'll go a little faster. The point is 2 comma 1. You go right 1 up 1 from the vertex, right 2 up 4 from the vertex, and right 3 up 9. Likewise, from the vertex, you'll go left 1 up 1, left 2 up 4, and left 3 up 9. And now connect the dots, and you've got your parabola. The axis of symmetry is right there. That's x equals 2. And let's just go on to the domain. So domain and range. Domain and range of this first graph, and you guys have space below this on your notes to write, I believe, so I'm just writing it up here so we can all see it on the same graph. The domain of every parabola is all reals, because you can always plug in any x value into a parabola. Now when we start talking about situations, for example using time or using distance, then that might be restricted, but if I just give you an equation, then the domain is all reals. The range, on the other hand, is always going to be related to the vertex. So in this case, because it's a minimum, we have that line right there, that horizontal line, is the lowest y value we can get, so negative 2. Oh, you don't have to butcher your graph by doing this, you guys, but I just want to show you all the things above that line are any of the y values that you can get. So the range is anything, any y, greater than or equal to -2. On the right here, we've got the domain, again, is all reals because it's always all reals. And the range is going to be anything greater than or equal to that line right there, anything above that line. So y is greater than or equal to -1. Now, on the back, what you see, you have your first glimpse of something I like to call a link sheet. It's called a link sheet because there are 4 different representations. You see the top left is a description, the top right is an equation and some things related to the equation. The bottom left is a table and the bottom right is a graph. And these are the 4 primary representations of a function. We're going to be using these link sheets for several units, so it'll be good to get comfortable with them. And one of the most important things for you to realize is that all 4 of these need to be closely connected. Now, I'll show you what that means a little bit once we have some of this filled out. So I'm going to fill out some of this. I'm going to let you fill out some of it before coming to class, and you'll come share what you've got with your classmates, and we'll do some more of these in class. So first of all, I want you to notice I gave you the equation on this one. I won't always give you the equation. Sometimes I'll give you a situation instead, or sometimes just a table, or sometimes just a graph, and then you would have to find the equation. But in this case, I gave you the equation. The vertex, you can see, because it's vertex form, is +2, 69.9. And the domain, because we just did it, is going to be all reals, although we're going to talk about that more in a moment. I'm going to put a big star there because this is a real situation, we might want to think about, well, does it really make sense to have negatives, or does it really make sense for it to go past a certain value? And then the range, in this case, we're going to talk about that some more as well. So on the graph, you're going to actually have to make the axes. Notice I'm not making my y-axis and my x-axis all the way to the bottom and all the way to the left. The reason for that is because I want to leave some space for labeling the axes with numbers and units. Okay, so see that space right there? That is going to be really helpful. Otherwise, you've got it all crammed in, and I can't read, and you can't read it, and it's just useless. So I am going to go ahead and give you a heads up on this one, just so that the whole class does it the same. Let's make those hash marks. Let's make each of those 1. That means that 1 up there is 7. And also notice I got the time. I got that from the equation where it says where t is the time in seconds, because that is the x value, or the input value. So you need to put both the word time on your x-axis, and you need to label it with units in seconds, okay? Now, if I didn't put seconds there, I could say 7 seconds and 6 seconds and 5 seconds and label each one even with just an S. But it is nice that if you ever put the unit in parentheses, that unit is applied to all the numbers. So by putting seconds in parentheses, I don't have to write seconds over and over and over. All right. Also, I hope you realize, put the 7 below the axis. I just, again, ran out of space on this tiny screen here. For the y value, go ahead and do this. Make every 2 squares, make that 10. So the height is the y value. And I'm going to have that in meters. So you see where I grabbed that from is up there. And the height, go ahead and fill out all the way up to 50, 60, and then 70. And that way we're all graphing the same there. While we're at it, I'll go ahead and fill in the table headers. So your y value is height, your output is height, and your input is time. And go ahead and put in parentheses meters and seconds. That way you don't have to label every single one. And just to show you what an example of what you might fill out in the x value column, I would probably want to start with 0. And we're going to look at that. You can talk with your group more about what that means in terms of this situation. And just fill out 0, then 1, then 2. And we know that because the vertex is at 2, we know the y value has to be 69.9 there. And go ahead and fill out 3, 4, 5, and 6. Now, you don't always want to go up by 1s on the x value, okay? What you want to do is you want to make it match the situation and the graph. So this right here should match your graph. Those x values, that domain, should match your graph right there. And that on the table right there, see how I go from 0 to 6 or 0 to 7, should match the table. The graph there should match the table. And those should both match the situation. So if it doesn't make sense to go up by 10s or by 2s or by 1s, then in the situation, then you shouldn't do that, okay? Now, I want you to go ahead and fill out the rest of that table using the equation, and go ahead also and graph it. Go down here. And then once you've graphed it and filled it out, you can use those two, and again, the order of this link sheet doesn't matter. You can do whichever one you want first. I then want you to look at the situation and answer those questions. Okay, it's always a good idea to read all of it first and then go back and fill out the parts as you need to. But the nice thing is you can fill these out in any order, and you're going to share this with your group mates when you get back to school tomorrow. All right, thank you for watching.